All right, wonderful geometry scholars. Two examples today. We're finding the area and perimeter in the coordinate plane. So we're taking what we've done the last week or two and putting it on the grid. So here we have 4 points, and the directions are to classify and classify the polygon and find the area and perimeter of the polygon. So let's graph them first. I have them pre-done. H is -3 and 4, J is 2 and 6, K is 2 and 1, and L is -3 and 1. I have the points labeled. I know you can't see it very well, but I'll connect H, J, K, and L. Okay, and that's the axis. 0, 0 is right there. So there's my polygon. Now, it appears to be a parallelogram. Listen carefully. It appears to be a parallelogram. You need to show that it is a parallelogram. All right, so you can't go by the way it looks. So you're going to need to know a couple of things throughout this week's lesson. Is you need to know the distance formula. There it is right there. The distance between 2 points. Now, if they're vertical and horizontal, you may count them. But if they're slanted at all, you need to use the distance formula, which is the square root of the difference of the x values, like in H and L. H and J is the difference between -3 and 2. Squared plus the difference of the y values, in that case 4 and 6 squared. Now, you can also, if you prefer, may use the Pythagorean theorem. Make a dotted line, make it a little square. You can use this slanted line as the hypotenuse. You may find the distance that way also. And they came from the same thing. So our goal is to classify the polygon, not by what it looks like, but prove it, and to find the perimeter and area. So, well, let's classify it. What do we know? It looks like a parallelogram. Did I say parallelogram at first? I think I did. But anyway, it appears to be a parallelogram. But how do we know for sure? Both sides, opposite sides, need to have the same slope. So let's do that first. HL, JK, they have the same slope. It's undefined. So HL is parallel to JK. Now comes HJ and LK. What are those slopes? The slope using the distance formula or the Pythagorean theorem, the slopes of both of those happens to be 2/5. They are equal. So because HJ is the same distance or is parallel to JK, we have a parallelogram. Opposite sides are equal. We took a little pause there. So where we were is we found that this is a parallelogram because the definition of parallelogram, opposite sides are parallel. That side's parallel, those two sides are parallel. And by finding the slope, we found that slope of these are vertical lines, they are parallel, and that's 2/5 for the other two. So definition of parallelogram, opposite sides are parallel. All right. So we classified it. We know it's a parallelogram. Now we get to figure out the perimeter and area. So now we got to figure out what these sides are. Now the first two sides are pretty easy. The first two, we know that HL and JK, 1, 2, 3, 4, 5. They both have a side of 5. Okay, I'm going to label that 5. All right, so that's half the battle right there. So the perimeter is going to be 10. Now we got to figure out though what the distance of this is. How far is that line? Okay, so we can plug in the distance formula, find the difference of the x values, subtract from the difference of the y values. We can also make a triangle. I think I said make a square earlier, but make a triangle and do the Pythagorean theorem. Either one of those two things will work for you. Whatever you feel more comfortable with. I kind of like the Pythagorean theorem. 1, 2, 3, 4, 5. 1, 2. Pythagorean theorem is a squared plus b squared equals c squared. 25 plus 4 equals 29. That makes this distance root 29. Root 29. All right, so we have root 29 for both sides, and we have root 29 for both sides, and we have root, pause a second. I lost my paper there, but I'm good. So we have the root 29 as this distance here. We have that as a 5. So the perimeter, 5 plus 5, which is 10. 5 plus 5 is 10. The perimeter is 10 plus root 29. Root 29 is 2 root 29. That is your distance, or your perimeter. Your area of a parallelogram, base times height. How do we do that? Well, let your eye turn this parallelogram. Let the base be one of these vertical lines. Let that be the base. Then the height will be just a 90-degree angle to the opposite side. So let's let HL be the base. We'll let the height be this line right here. Okay, the height is there. So we have a base of 5, a height of 5. So the area is 5 times 5, which is 25 square units. Okay, so 25 square units for the area of our parallelogram. And the perimeter is 10 plus 2 root 29. Now, when we're asking for perimeter, we were kind of asking for an actual number. So now you can break out the calculator, push a few buttons, and when you push in 10 plus 2 root 29, you will get, I'm going to erase this so messy for you here. It's going to be your final answer. I've been watching way too much Who Wants to Be a Millionaire over this quarantine. Is that your final answer? Yes. My perimeter is, I forgot what it was already. Oh, it's 10 plus 2 root 29, which is approximately 20.8. Yes, Jimmy Kimmel, that is my final answer. Approximately 20.8. So that's your first example, classifying polygons and finding the perimeter in area. They won't be as easy as just finding opposite slopes being equal, though, to see if they're parallel. You may need to find a distance formula. You may need to find bisecting angles to prove that a shape is what you think it is. So that's example 1. Example 2 is coming up next.